Okay, a bit about the talk itself. I guess a lot of people figured out that there was last year a big rant going on about being sun.misc.Unsafe removed from Java 9, including a couple of other APIs. We eventually figured out a way to migrate away from it. That was what all of us asked for. We all know that most of the software we today use at some point use one of these APIs, these internal APIs, which are not meant to be used, but, well, that's how it happened. As I said, we found a migration path, so we're over that. So I started to create this talk as an article on InfoQ, and it basically is selling a dream. That means this whole talk is a completely running target, which is good for me because I can give this talk all over again, and it's constantly changing. It doesn't matter to me. So the thing is, as I said, we found a migration path, so I guess it will be a good future. That's the reason why I tried to find a good post-apocalyptic picture. You would be surprised if you give a search for post-apocalyptic on Google and look at the pictures. Most of them have this Walking Dead feeling. That's not what you wanted, right? So I'm Chris. Just go for Chris. My official name is Christoph Engelbert, a German name. It works here. It doesn't work in Japan and a couple of other countries. I'm manager developer relations at Hazelcast. Unfortunately, I don't have to talk about Hazelcast. That's a good thing. That's your freedom when you're developer relations. I'm a Twitter fanatic. I think there is my Twitter handle. If anybody wants to have his timeline totally bursted, feel free to follow me. I'm doing Java for, I don't know, I think it's by now around 15 years. Most of the stuff is very, very internal. You see a lot of garbage collection, especially garbage collection optimization, but all performance-related things, and especially my favorite is fairy tale benchmarks. Who believes benchmarks are real? Okay, perfect. I see I have a good audience here. Or you're just tired still, I don't know. So the disclaimer, I was asked on Twitter when I first announced this talk, the question was, do you still rant about sun.misc.Unsafe being removed? And I said, no, this talk is not to be negative. Unfortunately, as I already said, all of that is completely, well, out of the blue. Nobody knows what is actually coming. It's a running target. The APIs are constantly changing, so what I tell you today might be totally outdated by tomorrow. But it gives you a nice overview of what you might expect to come, or what at least people in the JVM space are working on. That's quite nice. So I thought about, well, if we remove sun.misc.Unsafe, maybe we want to create a new class where we all put all this stuff, right? That is what sun.misc.Unsafe was, and I thought maybe we give it a better name, like sun.misc scissors, sun.misc running with scissors, something like that. There are always a good couple of things you can do. So what do you know about sun.misc.Unsafe, and what probably you don't know? I already said it's an internal class, right? Who knows it's an internal class? I think everybody, right? Okay. How do we figure that out? Well, we look at the class tree, and we see it's inside sun package. Fortunately, they haven't renamed it to Oracle yet. I think that will eventually happen. It is mainly used inside of the JVM, I think, or JRE. I think that is also very obvious to most of the people. We can figure that out by looking at some of the implementations. We all know, who knows Doug Lee, the creator of the concurrency package? If you know him, you probably know In Duck We Trust. So that is Doug Lee code. He's coming from the C++ space. Who can figure that out? I can, right? He doesn't like long variable names, like most C++ developers do. And I believe he's working in VI, but that's just my personal feeling. Well, and the other thing is it was used outside of the JVM. Quite a lot, though. For a couple of good use cases, like when you want to deserialize something and you want to make it fast, right? I mean, we're coming back to this in a second. It's just one example. But there were, unfortunately, a lot of bad use cases, bad practices, bad habits as well. And Mark Reynolds found, I guess, one of the best questions ever about sun.misc.Unsafe. And I'm very glad he made it, because I didn't have to search for it. So the question is, how can I free memory, an object memory, right? So we look up the code. He uses declared field to get the unsafe instance. And then he allocates an instance, which is, in this case, a player instance. So it seems to be like somebody working on a game. And well, then he asked, okay, I allocated it using unsafe, but how do I free it? And the best answer he could come up with is maybe using the hash code, because the hash code is some number thing. Who knows what happens when you try this, at least in like 99% of the cases? It will happen that. Who managed to segfault his JVM in the past? Oh, so quite a few people working with sun.misc.Unsafe? So that is, by the way, I used set native address 0. I just made it consistently failing. Set address 00, well, certainly writes to memory position 0, and that doesn't work, right? OK, so as I said, it was never intended to be used outside of the JVM classes itself. And I found a kind of proof for that. You can see there is like the 15th February of 1998. That is the oldest occurrence on the Wayback Machine. And the Wayback Machine is awesome. I mean, who saw the Google versus Oracle sue a couple of weeks ago? They used the Wayback Machine for every single claim. I think there would have been no claim if Wayback Machine is not existing. OK, so it was never meant to be. I think we don't need to argue on that. It was never meant to be used. But people used it for reasons of speed, for different kind of reasons. And it was mostly used by applications, frameworks, libraries. It actually is the other way around. So libraries introduced it. With libraries came the with the framework came the library, and you integrated the framework into your application. So basically, everything depends on sun.misc.Unsafe. And I just have a short overview of most projects that use sun.misc.Unsafe somewhere. That's not all of them. It's just like the very obvious ones. And I kind of try to figure out which are the most used ones. And for an obvious reason, I didn't make Hazelcast bold, but it would be the boldest of everything, right? I mean, obviously. But who uses Netty? Netty, OK. Who uses Cassandra? Hazelcast? OK. Things like Mockito, EasyMock, Hadoop, Spring. Well, you see, it's kind of a bad thing. Who believes that there are more? OK. So the thing is, the second claim that I often heard in the last year, talking about sun.misc.Unsafe, is that sun.misc.Unsafe only exists on hotspot JVMs. So there is no general use case for it. So why should you use it? And I tried to figure out that it is no. Fortunately, I did it. So that is a short table of all the JVM implementations I looked at that support either support or not support sun.misc.Unsafe. The green ones, obviously, are the yes ones, right? So my absolute favorite is, where is it? It's BKVM. It's a JavaScript and a JVM written in JavaScript. Unfortunately, it doesn't support sun.misc.Unsafe for whatever reason. Seems like browsers don't support memory access. I don't know. But even things like IKVM, the .NET implementation of the JVM, you can do that without any problem. So the claim is just wrong. Why is it wrong? Because sun.misc.Unsafe is so much used. It's not like the JVMs implemented it first and then people used it. It is because people used it. And when you want to run your Spring application, your Cassandra, whatever, on IKVM, they obviously have to support it. So let's look at a couple of the good use cases. And I think we're pretty good in time. So a couple of good use cases, low latency GC overhead. And we're just making short rating. Who thinks that is important? OK, perfect. So the way you do it, and this is very oversimplified, I have a flight weight object in this case, and it has a base address. And the base address is allocated somewhere. It has exactly 8 bytes, because that is what I need for it. It has exactly, oh, it's actually wrong. It should be, no, it's int, OK. So 8 bytes, 2 ints. I have an offset for both of the elements, x and y. And I just give the address of my current object I'm interested in into the getter objects. Well, we all know this is not getter syntax anymore. As I said, it's simply overfied. And you make getInt, you use the base address plus the offset of the element, and then you just go. That means we have 8 bytes to store 2 integers. Who knows how big this object would be in Java? So you have 12 bytes header plus 4 bytes for an int plus some space plus 4 bytes for an int plus some space. It should be around 20, 24, 32, something like that. So low overhead or low latency, GC overhead, obviously we just had one object, right? So fast deserialization, we already seen this, this example. What it basically does, this allocate instance, for the people that are not familiar with it, it generates an instance of the given class without running constructors. If I deserialize something, I don't want to run a constructor because I'm going to inject the previous state from my serialized objects. So why should I initialize the object? There is no reason for that. So that saves you a lot of time in a lot of cases. And there's one more thing. You don't need to have a default constructor to initialize the object. That's the second reason why people use it a lot for deserialization. The third big thing is 64-bit memory regions. Bytebuffer is a nice, kind of nice API at least, kind of nice, but it only supports 32 bits because all of the indexes, the offsets are 32-bit. So you can't go further. Who uses more memory than 32-bit can address? Okay. Do you think it will get smaller again in the near future? Probably not, right? So the way you do it is allocate memory, and you can give it as much as you want, pretty much everything that 64-bit can address. And, well, we've always seen this put get in thing. You can just give it an address. It can be a 64-bit pointer, and you just write to the memory address itself. This is very nice. A lot of people work around this by slicing down the byte buffers. Like if you want to have 4 gigabytes, you just take 2 gigabyte byte buffers. Is that nice? No, it's not. Why isn't that nice? Because it's just damn overhead you don't want to have as an engineer, right? You would have to have an array of byte buffers, and then you just calculate the index first, and then you go down and get the actual address thing. Not very nice. Another very important thing, atomic memory access. And that is not only true in this case, compare and swap. We have some classes that can do this for you. But it's more important for arrays. So who knows what volatile on an array does? I mean, we all know volatiles makes a memory barrier, right? We all agree on that. So volatile array is, unfortunately, only for the array, not for the elements inside of the array. So one of the important things where people use unsafe is to make atomic memory access to the elements inside of an array, because volatile just doesn't apply to that. By the way, they want to change that for Java in the future. So they're looking into a new implementation of the Java memory model. The next big thing, and we already talked about that slightly, memory efficiency. As I said, just to integer values, just 8 bytes instead of 30 or whatever it is. I would claim this to be very efficient. You just need to use a different way to access the object, but I think we're all good with that. Fast field memory access, if Shiplev would be here, I would make the claim that it is true in most cases. In some cases, whatever you want to call it. When you use unsafe to access fields and elements of classes, you always have to figure out if the access is really faster than the internal reflection access, whatever. There has been a huge amount of speed up, especially in reflection over the last JVM versions, like Java 6, 7, 8, all of them just get faster by a lot of tricks. In the future, we will have a better way, and I'll show you in a bit. So this is how you do it in unsafe. You ask for the field offset. So the version field is just the standard Java reflection field thing, right? You get a field offset, the same thing we already had. And if you ask for the exact version, you give. So there are two options. Either you give it a base address plus the offset, or in this case, you give it an object, and the JVM will itself figure out the address of this object plus the offset. You give it further, and then you just get the version or put something in. If I'm too fast, just slow me down. It's just like this thing has a lot of content. as I said, access to array elements in volatile semantics. We already had that. Very important. You get the base offset of the array, this index scale, which is how much space is between the different object or different elements, and then you just get the element itself using get_int volatile, get object volatile, whatever. Does that feel right? No, it's somehow not, right? And I think the last one is actually custom memory fences. That was just recently, I think Java 7 or 8, I'm not actually sure. I think it was Java 7 when they introduced it. It gives you the option to create your own memory barriers. And you can say, I just want to have a write barrier, I just want to have a read barrier, or give me a full fence. Just do whatever volatile does in all cases. Oh, it's not, right. There's fast interaction with native code. I'm not sure how many people do that. There are nice libraries making it possible to work with native code. I'm not talking about JNI, I said nice libraries. And the thing is, you always have to copy the data itself first to some off-heap location, to some native memory location, so you can give the pointer to the actual underlying C++ action. Not action, C++ application or library. So, and here it's getting tricky. How do we get access to sun.misc.Unsafe? We've seen one version already in the Stack Overflow post, but there is a simpler one. So that is the simplest version on how to get access to sun.misc.Unsafe. The problem is that only works inside the JRE or JDK classes. You have to be on the system class loader, and there is a check to make sure nobody else calls that. For kind of obvious reasons. It was actually added after they figured out people use sun.misc.Unsafe. There is an ugly solution, or probably still the most nice one. You get the field. It's normally called the unsafe. You make it accessible, and then you ask the unsafe class or the field accessor for, give me this very instance. So the unsafe system works with a singleton. We all know singletons are good things, and in this case, it's true because we can just access it right there. But this unfortunately doesn't work for all JVMs. So that is the code that actually works even outside of hotspot. For example, on Android, because the guys on the Google team, I'm not sure, Ray's not here, okay. The guys on the Google team decided, well, we're not calling the unsafe. That would be too obvious, right? That's what everybody does. We're Google, we can do something better, so they called it the one. It's like the Highlander. There's definitely only one. I already said it's a singleton, right? So it must be the one. Well, so what we do is we try the unsafe, which works on 99% of all the JVMs. And if that doesn't work, we're just walking through the class itself, looking for all the fields, try to cast it to unsafe, and eventually we figure something out like the1 or whatever people decide to call it. And if nothing works, well, we're bad to go, not good to go, and we're just throwing some runtime exception error, whatever. So that actually works on, I guess, every JVM I tried that supports sun.misc.Unsafe in some way. But there's one more version, and I really like that. Who knows Charles Nutter? The JRuby guy? He probably came up with the best version I've ever seen, and I cannot stress this enough. Unsafe is a singleton. So what do? We just create our own unsafe instance. So we just don't care about any pre-made instance. So who believes that singletons work in Java? Sorry, no. Unfortunately, they don't. The thing is, we've seen a couple of versions, but does any of that feel right? I don't think so. I really don't think so. And that picture is real. One of our co-founders took this, and it's the restroom of our first office in Palo Alto. So this is real distributed computation, or parallel computation. It unfortunately had just one door, for whatever reason. But no, it really doesn't feel right. And I don't know. I don't know who took this picture. I just love it. It's, by the way, I think it's the German fire department, or it's one German fire department, so they're not all geniuses. So, the whole thing started when the OpenJFX, which is the open source project behind the JavaFX project by now, got asked about, hey, when you remove sun.misc.Unsafe from some other classes, we really have problems. And that was an answer that came to the mailing list by Donald Smith, Oracle employee. And he said, well, sun.misc.Unsafe must die in a fire, and ignore any kind of theoretical rope. Okay. Well, kill unsafe dead, kill unsafe right. And I read this email, I read it twice, and I had this strange feeling that Oracle somehow created some kind of new task force. And I thought it like, maybe kill unsafe total death, I don't know. But I got back to this email, and as I said, I read it again, and I eventually figured out there's one very, very good sentence, and that is unsafe. If you're using unsafe, this is the year to explain where the API is broken and get it straight. So a lot of fuss in an email around one very important sentence. I think that's a good quota for writing your emails. It looks at least important because there is a lot of stuff around it. So, and we have 28 minutes, that's pretty good. So that is what actually is coming, or is supposed to come in some way or the other. So the first thing, atomic updates. We talked about that, right? You can do it with unsafe, compare and swap long. You just do a while loop. It returns true or false depending on if the value was updated. Who knows how compare and swap works? I think I didn't need to explain it. Well, maybe. So the way it is, you store the old version. It's like optimistic locking. You store the old version, you create the new version by some calculation, +1. And then you say, OK, now compare the old version if that is still valid. And if it's still valid, atomically exchange it with a new one. And that returns either true if it could exchange it because the old value was still valid. Then you're good to go, and you return the new version, or you break from the loop, whatever. Otherwise, you retry. That means you read the new old value, which is now the valid one, and you hope that it is going to be the still valid value when you retry. We can do this in a more Java-like fashion, and I think that is something that maybe a lot more people know. And that is something like atomic long, atomic integer, atomic references, atomic whatever. Who knows that? I think that is, you see? That is what way more people used. So there's one problem. Imagine you're writing a record store, and every record has to store its version number. So there's one big problem, and we talked about it. It's GC pressure. Because now I'm creating one more object for just a version field for every single record. And a version is normally not the only thing you store in a record. There's a timestamp, creation timestamp, there is maybe a TTL, you get the point, right? So we create way more overhead on object size for just one very object, or for one record that could be a single object. There is a better version, and I'm not sure how many people used field updaters. At least a few. So field updaters do the same thing, but they do it with reflection magic. So you give it the version number, you make a static final out of it, so you just have one version to update all the fields, and it still does exactly the same thing. And by the way, there's one important thing. Do your colleagues a favor and tell them in a comment, this field is going to be updated, even though your IDE won't figure it out, because it's updated through the atomic field updater, which means they use reflection. If you have Eclipse or IntelliJ, and I think it's also true for NetBeans, even though I don't like it, but NetBeans should also be able to figure out this field is not updated from your Java code. But it still works. So you use the atomic field updater, you say increment and get, and you give it the current instance of your object, and it will figure out, OK, the version field, blah, blah, blah. OK. So that is what's coming in the future. That is very, very near future, though. There is something which is called a VarHandle. Who knows method handles? Introduced in Java 7, OK, quite a few people. The interesting thing about method handles is the JVM is free to inline them. That means it can inline the call as it would be done in pure Java code, if you would have done it in your Java application, in Java source code. The same thing goes for VarHandles. When I'm doing this find version VarHandle thing, I'm creating an accessor to this field as it would be created by the JVM if I would do it in source code. And I can do cool things like add and get, which does the same thing as increment. It's just like, well, you add and 1. I'm not sure if we need an increment and get, or if we can just say add and get and 1. I think that's kind of equivalent, but OK. So same thing here. Please make sure to tell your people this field is actually updated. Whereas I think that eventually the IDEs will be able to figure out there's a VarHandle access, so that means the field is somehow updated and somehow read. So how do we get a VarHandle? I said method handles, and that's what it is. A method handle and a VarHandle do only look different from the API that comes out. A VarHandle has slightly different API, but it's kind of the same thing. You get the lookup object, which gives you access to all the internals of the methods and fields, and then you say, OK, please give me this field VarHandle for a class, for the record class, the version field. Unfortunately, there's still no way to make this type safe, and say there's a long. I think it's a long, right? I think so. We all know this problem from JPA and other stuff. When you integrate types and strings, one of those things changes. That's always a bad problem because there's no way to automatically fix those errors. But it works. It works amazingly fast and amazingly nice because the JVM, as I said, inlines that as it would be a direct access, as I would ask the version field itself for value. And that's very, very important because that gives you this nice speed of native Java applications. OK, the second thing, memory management. We already seen that, right? We allocate some memory, and we put in a value. We can read the value. Same thing here. So you can do this with byte buffers. I already said that, as long as you're good with 32 bits. Byte buffers are a perfect replacement. Allocate direct allocates native memory. Who used allocate direct instead of byte buffer allocate so far? OK. So as I said, the difference is allocate allocates your in this case, 8 bytes on the heap. Allocate direct will allocate it outside of the Java heap, which is very nice because that means the garbage collector doesn't have to work with that. So again, put, get, I think that's easy. I think almost all people know byte buffer API. But we're going back to the VarHandles, and we again allocate our byte buffer. And now VarHandles not only have field access, they have also another very, very interesting feature. And I can create a view on a byte buffer. So I have 8 bytes, and I can say, hey, please, well, it doesn't make sense for 8 bytes, but it would make sense for 16 bytes. I can say, please make this look like a long array. So with 16 bytes, I would have 2 elements in my long array, and I can actually access them the same way as it would be. That means you don't have to write your own abstraction on top of that. That is what most people do. Just a small feature, but a very nice one. It actually works the other way around. So if you have a long array, you can make it look like a byte array, which is nice because then you have bigger byte arrays than 32-bit. That is something that I came up with from my discussions with Paul Sandos. I said 64 bits are a common thing. We already have applications using more than 64-bit memory. Hazelcast can allocate without any problems up to 500, right? 500 gigabytes. That's not possible with byte buffers. So there must be some way to allocate this in the future. JVM space won't get smaller. We're only growing here. So what we came up with is something we called memory region. And you say, please allocate me a memory region, and you give it a name for JMax purposes, whatever. And you also give it a size, and you say, well, please make it unaligned, make it aligned, depending on your performance preference. And then you use this view thing again, and you say, please make this memory region look like a long array again. And then you use it the same way. So the thing is, as I said, this was what I came up with as an API from the discussions. That is not what it looked like. It was even better. So we now get a scope. That is actually already a working prototype. So you get a scope, and in a scope you can have multiple allocations. And the good thing is a scope is auto-closable. That means whenever you leave the scope, it will automatically deallocate everything for you. That's perfect. Who knows, C++ deallocators will love this feature. And inside the scope, you allocate something. You say create a layout, which will in this case look like a long array again, and give me the number of elements, for example, 10. So it will figure out a long array means I have 8 bytes per element. I need 10 elements, so I need 80 bytes. OK. And what you get out of that is a pointer. Who believes that Java always needed a pointer class? Perfect. At least a few people. It's even get better, so your pointer can have an offset, which is in this case the index of the array, and you get a reference. Who thinks Java needed a reference class? Right. And there's, by the way, one important thing about the pointer class. I think it's still true, even though I couldn't figure it out last week. When I first looked at that, the pointer class had one very specific public static final constant, which was a constant to access memory location 0. And who can imagine what this constant was called? Null pointer. So there really was a chance to get the first real null pointer exception in Java. Awesome. I love this API. No, really, I love this API. So I think that is way better from whatever I could come up with. And this was a very recent. I said this is a running target. When I last gave this talk, it was like 2 days before. So it's really a running target, this talk. And it's really nice. I love Vladimir for that. OK. Deserialization, we already had that. As I said, if you deserialize state from an element, you don't need to initialize it. For certain things like strings, it's even better because for a string, who knows what happens if I pass in the char array into the constructor that takes a char array for a string? Right, it will create a defensive copy. Do I need that when I deserialize the char array? No. Why do they do it? Well, because people do stupid shit, right? We all know this. We all have this one colleague who always does the stupid shit that we have to fix. Anyone disagree with that? No. So that's the reason why you get defensive copies. But when I deserialize something from stream, I just use this char array, and it doesn't even leave the method. So I definitely don't need this defensive copy. What I do here is I put it into the string afterwards, and I say do it with volatile semantics, because I want to make sure that the object is visible to all threads after creation. Because strings are immutable. We all know this. Kind of a weird thing. Unfortunately, it works. It will probably not work, or most probably not work with Java 9 anymore, because they exchanged it. There is no char array anymore. There's a compressed byte array, which kind of encodes the internal representation of the strings for memory saving reasons. So they're not making 64-bit APIs. They're just compressing strings. Also a way to solve this issue. The other, what is supposed to solve this issue? There is something which is called reflection factory, and reflection factory can create constructors that are not available in the class. That means it actually creates a default constructor that is not available in the bytecode, and you can already use this API. The only thing, I think it's sun.misc reflection factory, something like that. What is supposed to be happening is that they move this API to Java reflect something, Java lang reflect something, and make it a public API for exactly that very use case. For nothing else, just for that use case. And that's good enough, right? We just want to create objects without doing any of the stupid shit. Well, we already talked about, on the other side, about interoperability with native code. Who remembers that? JNI code? Who did JNI code? Who still does JNI code? No. Does that look good? No, it's not. So how it works is you create your method in C. You have your implementation somehow. And inside of Java, you have this class, you have a static load library, blah, blah, blah thingy, some magic, and then you mark your method as native, and you give it the same ID as this magic method identifier in JNI, right? This Java process identifier, get process ID. It kind of seems familiar, but that doesn't look right. There are a couple of options to work around that. We really don't want to write JNI code. That's like the worst thing in Java ever. I'm really sure that this was not created for public review. It was just created for some internal prototype. So the other way to do this is using something like JNA, JNR, Java native accessor, Java native runtime. Those things make it way simpler. You just create an interface. In this case, I called it libc. And you use getPID, which is the Linux syscall for getting your own process identifier. And then you say, OK, here's my library loader, and this is my interface, and please load it against the standard C library, whatever that is in the current implementation or current operating system. So it could be libc, it could be glibc, whatever is out there. And then you just call it. No magic, no JNI code, no C code. You just have your method and an interface. And that API or that idea was so important and so amazing that they said, OK, we moved that into real Java code. That is Project Panama. Project Panama is, so the memory region stuff is also from Project Panama, because they obviously need those memory regions to interact with native code. So we're back to the method handles, and this time we have something new in method handles as well, which is find native. And you say, OK, this is my method name, and this is my parameter type, in this case just an int, which doesn't make sense because it's not the parameter type, it's the return type in this case. Because it returns an integer, a 32-bit number for my process identifier, and this magically binds your Java code to some native call, which is called getPID. In this case, it will automatically figure out that it is some C library. And then you invoke it. That's it. The good thing here is the JVM is free to inline this right to the native call. That means when the JIT compiler comes through and optimizes that, the only thing that happens to be left is getPID as a native call, plus the conversion of the C integer to a Java integer for the return type. That means if you look at the JIT bytecode, the JIT assembler code, it will actually does the getPID call right on the spot. That's impressive. That's important because it works around all this JNI shit we had in the past. There's one more interesting thing about it. 12 minutes left, OK. There's one more interesting thing about it. They really think about supporting custom intrinsics. Who knows what intrinsics are? Some people. Intrinsics, so for intrinsics, it's basically a native replacement for a Java method. You have a calculation in Java, which acts as a fallback if the CPU doesn't have a special opcode. But if your CPU has vectorization, whatever, they are free to exchange it with some intrinsic, which obviously works way faster because it works on the native hardware. And that is important. If you look at a library, we could provide our own Java implementation. It doesn't need to be the fastest. It just needs to be right and work. And when we figure out we are on the Oracle, Spark, X, blah, 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 whatever special CPU, we know there's a special bytecode, and we can just inject that as an intrinsic, which makes it just faster. And it's automatic. That's the nice thing. And I really hope this is coming. I'm not 100% sure yet, though. I just want to see this first. So who heard about value types already? I mean, that is something that most people, well, I see some people like, maybe. So value types are a new type of class in Java. And this is actually coming pretty soon. The difference is a value type, and I like the sentence that Brian always uses, is it works like an int, it codes like a class. That means this object looks like a class to you. You can use it like any other instance, any other class field in Java, any other class in Java. But the way it is represented it really is just this X and Y stuff, as long as you don't need anything like an object header, for example, if you use this in a synchronized block. There's one more important thing. You can't create it as an object, because it's not an object anymore. And that is what it is represented like. As I said, it's just an array of the values, which is very nice because the JVM can do something, or you can force the JVM to do something which the JVM currently tries to figure out, so you can help it. At the moment, the JVM does stack allocation whenever it can figure out that an object that only consists of primitive values does not leave your method. If I don't leave the method, I don't need the object, as long as I don't need it for synchronization reasons, whatever. So that means if I have this point class in Java right now, and I do some calculation, the JVM can figure out, oh, OK, it's two primitive values, it's 2 integers. You do some math calculation on that. Well, I can allocate those 2 integers and simulate the rest around it. OK, fair enough. The good thing is, as I said, you can now tell the JVM, my value class, I want it to be stack allocated because I know it's a value type. And value type inherently means it only works on values. So that is one of the biggest things in Java to come, stack allocation. I think that is one of the most requested features looking for the bug tracker of Java like forever. I don't know. I think there are 300 answers on this feature request. There's one more important thing, and that plays very nice with value types, and I need to speed up a bit. This is specialized generics. Who knows templates from C++? Who loves templates? Who thinks templates are important? OK. So do you love generics the way they are at the moment? Somehow, right? They do a great job in most cases, unfortunately not in all. So what is coming is some kind of template system in Java. I call it templating. I think that Brian and some other people would kill me for that. So what is coming is the so-called any thing. Any T means this box can really hold any value. So T is still my type parameter. We know this from generics. But what we can do now is I can say I want to have a box of ints. And since it's a value, a template, it will have int here and int here. That is how it is represented. That means no autoboxing, like for list integer or something. No magic going on underneath. It's just a box of integers. And I could do the same thing. I want a box of strings and a box of random class. And how it works internally is the JVM will spin an instance of that class for this very specific type. That means there are 3 different types represented by the same template class, the value, the any T class, whatever you call it. And that is interesting. They're obviously not assignment compatible. I can't assign a box int to a box string. That is not possible with generics either. Yep.
Can you call any methods on any T?
Yeah. Well, you can when you specialize it with a type. So the question is, can you call methods on this? Yeah, you can. No, you can't, because it's just a template. Whenever you specialize it, you get the specialized version. It obviously works for static methods, though, if that is the question. You can call static methods because they don't have a generic type. They're working on this as well. I forgot the name, how they called it. So there is some special modifier coming for generic static methods. Don't ask me. I forget the name. It was kind of a cool thing. I never heard about it before. So as I said, that means you can have a box int. And this set1 really means there is an integer being passed in. That's important because out-of-boxing, I'm not sure if you guys figured out, but as I said, I'm really looking into garbage collection issues. Out-of-boxing can be a huge pain in the, you know what I'm saying, right? So out-of-boxing can be really big problem for garbage collection, especially if you just do it over and over again. You really see that if you're not using values up to 128, which is a nice value, unfortunately most of the time too small, you get a new instance all the time. And that means the garbage collector has to actually create instances. Or the JVM has to create instances, and the garbage collector has to clean it up. Together with that, Arrays 2.0, one important thing to mention here, no 32-bit integers, indexes anymore, 64-bit for everything. You can shut down arrays. That is something that is already implemented. So for the first time in Java, you can say, oh, I have an array of 200 elements, but I really need 100, so please chop it down. Very important, because you can leave out the copy of the array elements. We have this. Who figures out what is wrong about that? Yeah? It is not safe, right now at least, right? So why is it not safe? Because it's a generic array, and arrays are not generic. That means it is possible, you can do that, but the JVM gives you a hint, hey, by the way, this is shit what you're doing. You are now this colleague that does shit, right? In Java 10, probably, it will work, because that is the box element with NET. That means we have a very specific type here. Apart from that, it will work with the normal generic classes as well. So they figured out how to do that, which is good. Well, you can do that. It makes it just more obvious that it is the NET type. Frozen arrays. Who needed that in the past? Frozen arrays, arrays where you can't change the elements. Just 2 people? 3? 4? Come on. You figured out that you can't pass an array and make sure that your colleague is not doing any stupid shit with it, right? Oh, you don't pass arrays. OK, that's a good point. So point class value type again. An array of a value type is allocated as that. So it's a very, very nice linear allocation. As I said, stack allocated. And let's see, 3 minutes. Cleaner API, somebody knows that? Cleaner API? Nope. It's around since Java 1.4. We're going back to the direct bytebuffer, which comes out of this direct allocate direct. And to make allocate direct working and to make sure there's no native leak, because it's a bytebuffer and that is garbage collected, they created the cleaner API, which registers itself as, I think, a weak reference or something. And when the byte buffer runs out of scope, is not used anymore, all references are gone, the cleaner will make sure that your memory of the byte buffer is actually cleaned. That API is going to be public in Java. There's a working prototype for that. It is auto-cleanable, auto-closable, actually. It's auto-closable. And you get a state, you store your state, and there's the cleanable API. That is very nice, because that gives you, for the first time in Java, a real deallocator, deconstructor. And please don't tell me that finalizers work. So there's a couple of more exciting stuff. 1 minute, 40 seconds. That is very good. Class dynamic. Just going through this quickly. We already talked about templatings. They figured out when we have templates for NET, we can make templates more generic. So you get some AOP-like APIs. AOP, aspect-oriented programming. Yeah, OK, some people at least. What is it normally used for? That is a very bad example, so I figured that out. Let's use logging. Everybody understands that logging is a cool thing. You have your template, and you say, whenever you apply this template, please log before you're executing the underlying method. Execute the underlying method and tell me that you did it. So you can just do this as a template and apply to any class. It will just spin up something. That's pretty cool for enhanced proxies and kind of things. Spin wait hint, going into Java 9. Some CPUs, I already said Intrinsic, some CPUs have special opcode for permanent loops, for busy spinning. So what the guys at Azul Systems came up, the guys behind the Zing JVM, the continuous compacting, whatever it's called, garbage collector. They created this thread on spin wait, and that gives the JVM a hint. Hey, if I'm running on a CPU that actually supports those opcodes, please execute it now. Otherwise, it's a no op operation. That means if the CPU understands that, it goes into a special state where it doesn't do this busy spin, but it just waits until something happens. Okay, and that I think is the real finish of the talk. A lot of stuff is changing. You've seen just, I think that is probably like 60% of all the stuff, and we're already out of time. So a lot of stuff is changing. The JVM and the Java itself will be different in the near future and in the far future. As I said, it's all selling dreams. It might change over time, but don't forget to try Jigsaw right now. If you have Java, or if you want to run on Java 9, try Jigsaw. It will break your application and make sure that it breaks and that you claim Oracle where it breaks and that they solve it. Otherwise, we'll get a big problem with Java 9. And that is, that is something that everybody says. And if you want to know more information, there are quite a few information things that you can read, specifications, blah, 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 blah. Just a few of those, and I think there are some more. So feel free. Otherwise, if you have questions, come by the booth. We're, as I said, already on time. And OK, thank you.